All right, so we are doing day 3 today. This is the last day of notes before you stop and review for a couple days, and you will have a quiz after that. So this is the last new material before that quiz. It's all about area of squares, rectangles, and parallelograms. Here's some information on the area of squares and rectangles first. So first we'll just define area. It's the amount of surface covered by a figure. It's measured in square units. So I like to think of area like if I was going to paint a wall, how much area would I have to cover?
The whole wall.
No, that was a rhetorical question. That's what area means, okay? Like how much surface is there in a flat figure, okay? It has 2 dimensions, yeah. So to find the area of the square, remember in a square all the sides are congruent, so you just take that side and you square it. Rectangle is very similar, but remember that we have 2 dimensions for a rectangle. Opposite angles are congruent, so you take the base and the height and you multiply those together. Some people call this length and width. That is fine as well, okay? And then units are always written as whatever the unit was squared, okay? So if it was like inches, you'd put IN squared. When you say it out loud, we say square inches, but it's written as more like inches squared. So I want to find the area of this quadrilateral. Assume it's a square.
30.
No.
Oh, you squared it. My bad.
How do you find the area of a rectangle?
Times width.
Length times width, or base times height. So we are going to multiply those 2 together. 54 square inches. Questions? Right, yeah, you don't square the actual numbers, you just write the squared in the answer with the units. The reason we do that is because like 9 inches, 6 inches, you're multiplying the inches by inches, so you just write it as inches square inches. And yes, you must put square inches. That was for you. Okay. All right, here's number 2. So now I'm looking at a square. So I only see one side length. How am I going to find the area?
11 times 11.
Yeah. And you could actually just remember base times height and do it here too. You just have to add the other 11, 11 times 11. Yeah. So it's 121 square meters.
I always used to think 11 times 10 was 110. Wait, is it?
Thank you. Yes. It's a good little algebra lesson for the end of the first half of the chapter.
I was bad with multiplication.
All right. Here's where it gets fun. Okay? So we will also look at these, and tomorrow you're having a whole review packet just on area, and there are 2 pages like this. So you got to be aware of how these work.
Miss Money, you said it was going to be fun. That don't look fun.
This is super fun. All right. So the way you want to do this is take it apart. So if you can find the area of this guy and this guy and this guy, you'll be able to add those separate chunks together to find the area of the whole thing. Okay? So check out, what do I already know? Let's do this guy right here. Do I know both of the dimensions there?
Yeah.
And what are they?
3 and 4.
Okay, so I'm going to multiply those together, right? And what do I get for the area? 12. And I'll do the units at the end. I'm just worried about the numbers now. All right, let's look at this little hunk at the bottom because I think we know both dimensions there as well. How big is that?
10.
Yeah, it's 5 by 2. So just multiply the 5 and the 2 and you get 10. Now, it's not so easy with these other guys. This one, Now, I would assume the 9 is just from here to here. Do you see how it's for like the 7, it tells us it's from here to here? For the 5, it tells us from here to here. Since it doesn't specify, I would assume that the 9 ends right here. So I'm going to call this dimension 9 centimeters. Okay? Now, I need to find this one.
Is it like 3.5?
How would you get 3.5?
Split 7 in half.
Okay, so if this whole side is 7 and this side right here is 4, you're telling me how much would be left over here? 3. That's exactly how you have to do it. So this whole segment over here is 7 centimeters, right? This is a rectangle 4 and 4. So if I start with 7 and I cut off this hunk that's 4, how long would this one have to be? 3. Yep. You could also go from down here, see how the whole thing's 5? And then it tells us this little guy's 2. Well, 5 take away 2 means
7. No, 3.
3. Yeah, so either way you approach it, you'll get 3. So 3 and 9 gives us what for the area there? Yeah. So the area of the purple figure is 27 square centimeters. The area of the red figure is 12 square centimeters. And the area of the long blue one at the bottom is 10 square centimeters. When you add those 3 together, that'll give you the area of the whole thing. 49. Good.
Lost.
Where did I lose you?
Oh, no, the 49 is lost.
Oh, the 49ers lost. I thought you were lost.
Not yet.
All right. We have another one to look at, very similar. All right. Now, is there any figure that we have both dimensions for? I don't think so.
Why did you say 3?
What now?
Your 4 is my 3.
Here?
No.
Here?
Yeah.
Okay. Well, that didn't work. All right, how's it look now?
Now.
Okay, so I am gonna first, I'll just focus on this guy. So I know I have 2 this way. So what's going on here? Any guesses?
Is it like it look like it's like.
You can't just say it looks like it's like.
Well, that don't look like half of this.
If you take 12 and subtract it from 6, you'll get the bottom measurement of the top rectangle.
Okay, well, if you take 3 from 12. I don't like this.
You gonna get 9. 9 times 8.
Okay, so you're both sort of saying the same thing but from different angles. So I'm just going to kind of use this kind of like a ruler, okay? So if I go from here to here, how long should this guy be? 6. It's the same as that, right? And then from here to here is how long? 3. I just stole these measurements. 3 and 6. So this little chunk right here has to be how much? 3. Okay? So going this way, 3 and 3 is how long? 6. So I will do 6 times 2 to get this area. What would that be? 12. Good. Now, for this guy, how long is this side? 6 and this little hunk is 3.
9.
So 9 by 3.
27.
Good.
Where you getting 9 from?
Because this is 6 and this is 3. And 6 plus 3 is 9. So 9 by 3. All right, now what do I do with those two areas? And what do you get? 39 square meters. What? So on number 5, is there one of the rectangles where you already know both ways?
Yes.
Yeah, which one?
Bottom.
You already know this.
Yeah.
You already know this.
Yeah.
You don't even know either of them down here, so I don't know what you're talking about. Up top,
Up top.
I have 3 and 7.
21.
Very good. So there's usually one that's pretty simple. 21 square meters is the area of that one that I just traced in red. Now, the bottom, as I was pointing out, I don't know either dimension. So check out this side. If this whole thing is 6,
Okay.
but this hunk is 3, how long is this segment down here?
3.
Also 3. You just subtract this portion. The whole thing is 6. I already used 3 here. The other 3 would have to be down here. All right? Now, if you're going this way, we have 7, but 4 of it's right here.
So it's 3.
So it's also 3. You just subtract this segment from this segment. Okay? So that's 3 as well. And what's 3 times 3?
9.
9. Now I take those two, add them together.
30. Last one.
All right.
Go. Let's start with 4 and 15.
15 is not the side of any of these figures. 15 is this whole thing over here.
3 and 7.
Okay, 3 and 7. We could definitely start with 3 and 7.
21.
So yes, I don't really have space to write it out, but 3 by 7 would give us the area of 21 square meters. All right, now over here. 10 and 4. 40. All right, so down here I have 14, so I'm good to go. I need this guy right here.
4, 5. 4 minus 15 minus 4. It's 5.
Yeah, so this whole thing is 15. From here to here is the same as the other side of that rectangle, so it's 10. So 10 from 15 leaves us with how many?
5.
5. So we'll do 5 times 14 down here. And I'll write that one out since I have the space for it. So what do I need to add to get my final answer? 21 plus 70 plus 40 equals what? And don't forget the square meters. Questions? We're not done. It looks like a few of you are trying to like transition to be done.
That's the last one.
It's on new notes.
This doesn't. You don't have parallelograms on yours?
Yeah, the parallelogram and raw boost.
Yeah, we do.
Yeah, we're just gonna do the parallelograms part. All right. So the base of the parallelogram is either pair of parallel sides. So the base is always a side. The height is not necessarily always a side. The height is the shortest distance between the bases. So the base is a side. The height is not a side. Usually not a side. For the special parallelograms, it will be a side. All right.
Bless you.
So this is what a parallelogram looks like. And the cool thing is that it's basically the same thing you do with rectangles. You just multiply the base and the height. The only difference is the height is not a side length unless it is a rectangle. All right, so here's how we find the area. Base times height. Did you all get that? Yeah. Okay. All right, so here's example 1. How will we find the area of this parallelogram? Yeah, so just 7 times 11.
77.
77, and we're still talking about area, so you still need the squared after the unit. So 77 square units. In this case, square millimeters.
But you can't.
All right. Yes, you have to use units. Okay, so this is what it might look like. Sometimes the height is written in the figure, like you just saw where it's like a dashed line. Sometimes it's written out here. It just kind of depends on how like narrow the figure is. But we're still going to use the height, which isn't necessarily a side, and the base, which is a side. So how will I find the area here?
What's the box?
14 times 6 or 6 times 14.
84.
Very good. Make sure you use your units. All right. So you might also see them like this where it's kind of in reverse, and there are a bunch of these in the packet you're going to get tomorrow. It says A gives the area of the parallelogram, find the missing measurement. So if the area is 72 square inches and the base is 12 inches, how high must this thing be?
6.
So the way you do it is you write an equation. Take the A out, put the 72 in. Take the B out, put the 12 in. And then I saw a bunch of you doing it in your calculator already. You just divide both sides by 12, and you up with a height of 6 inches. Now, here we did inches squared or square inches divided by inches, and you end up with just inches, okay? Don't put square inches when you're talking about base or height. These are just single measurements, one dimension, like measuring a line segment, okay? Yes. Just parallelograms.
We ain't got to square it.
No. All right. How will I start this one? It's going to be 6. Where'd you get 6? Right, so you do 30 equals b times 5, because 5 is the height. Divide by the height. We get a base of 6 meters. All right, so your notes start talking about rhombuses after this. That's where we'll start next week. Up until here is what you will see in your reviews the next couple days, and on that upcoming quiz, okay?